Okay, this is lesson 7.3, which is factoring complex quadratics. And we're going to be using the box method to do that. So the box method, just so you know, comes in really handy when you're dealing with complex quadratics. And a complex quadratic is when a is not 1. Okay, so that's kind of the key. So let's first compare the two methods. I'll do this problem first using the M&C method, then using the box method. So if we want to factor this, since it says factor, we know it's going to be the product of two binomials. Okay? And the product of two binomials has, if you remember, x plus m times the quantity x plus n, where m and n need to multiply to give us 12 and combine to give us 4. So we're going to put a negative 12 over here and write the factors of negative 12, 4 and 3, 6 and 2, 12 and 1. And we want to look in this list for the two numbers that combine to give us a positive 4. So 6 and 2 can combine to give us a positive 4 by making 6 positive and 2 negative. And negative 2 times 6 would be negative 12. So positive 6, negative 2. I'm going to do the same problem using the box method. So here's how the box method works. First term goes in the first box. First term, first box. Last term goes in the last box. Last term, last box. Then A times C will go in this T-chart. So A is 1, C is negative 12. So this is negative 12. The T-chart is the same. So 3, 4, 6, 2, 12, 1. And it also serves the same purpose where we're looking for the two numbers that combine to give us the middle term. Now, if you remember, since this is the box method, we would multiply a binomial times a binomial. So these are the two terms that we would add together to get this one. And that's what this list is. So this is a positive 6x, and this is a negative 2x, because those two terms would combine to give us positive 4. Positive 6x, negative 2x. Okay, so these two terms just go in the two boxes. It actually doesn't matter which box they go in. Now we're going to take the GCF. So the GCF between these two columns, or sorry, these two boxes is just an x. The GCF of these two boxes, they're both 6 times something, so it's a 6. The GCF of these two boxes, they both have an x, so that's it. The GCF of these two boxes, they're both 2 times something. Now, to figure out the signs, whatever sign is in this box comes out with it. So since this is a positive, this is a positive. Since this is a negative, this is a negative. So the answer is x plus 6, x minus 2. Okay? So number 2, you know the C&M method, so I'm actually going to skip that, and I'm going to go straight to the box method to give it a second shot. Even zoom in. So in order to factor this, we still factor out the GCF to start with. So since all of these are divisible by 2, I'm going to divide each term by 2, so I factor that out. I'm left with x squared minus 5x minus 24. So I know that my answer will be 2 and then times a binomial, To figure this part out, I need to factor just this part. Here we go, box method. First term, first box. Last term, last box. Then A times C will go in the T-chart. So that's a negative 24. 1 times negative 24. I'm going to write down all the factors of negative 24. 8 and 3, 6 and 4, 2 and 12. And I'm looking for the two numbers that combine to give me a negative 5. Well, 8 and 3 can if 8 was negative and 3 was positive. So this is a negative 8x and a positive 3x. Those two terms go in these two boxes. Negative 8x, positive 3x. Now, before I take the GCFs, I'm actually going to take the signs out. And now I'll take the GCFs. The GCF of these two boxes is just an x. The GCF of these two boxes, this is 8 times 3, or no, 8 times 1. This is 8 times 3, so the GCF is 8. The GCF of those two boxes is just an x. The GCF of these two boxes, 3 times 1, 3 times 8, is a 3. The answer is x plus 3 times the quantity x minus 8. Now, here's why we like the box method. Let's go ahead and give number 3 a shot. If we wanted to factor this one, first we look to see if there's a GCF, which there's not. Then we'll go ahead and use the C&M method. So we're looking for two numbers that multiply to give us 20 and combine to give us 13. 2 and 10, 5 and 4, 20 and 1. I can't combine 2 and 10 to get 13. I can't combine 5 and 4 to get 13. And I can't combine 20 and 1 to get 13. So actually we can't factor this, or at least using this method. Let's try it using the box method. First term, first box. Last term, last box. Then A times C goes over here. So 2 times 20, which is 40. All right. Factors of 40, 4 and 10, 8 and 5, 2 and 20. Sure, there's more. But I'm looking for two numbers that combine to give me 13. Well, 8 plus 5 is 13. So positive 8x, positive 5x goes in these two boxes. I'm going to quickly take the signs out. Now take the GCF. GCF between these two boxes, just an x. GCF between these two boxes, this is 4 times 2. This is 4 times 5. GCF between these two boxes, they both share a 2 and an x. GCF between these two boxes, 5 times 1, 5 times 4. So our answer is 2x plus 5, x plus 4. Since we have the box method, it works with anything. It doesn't have to just have a equal to 1. Let's go ahead and do 2 more problems together. So with this one, there's just one key factor, one key point when we're doing factoring, and that's that A must be positive. There's no options there. So remember, A is the coefficient of x squared, and see that this is a negative 4. We can't factor it when it's like that. So we first need to divide every term by negative 1 so that we can factor that out. And we're left with 4x squared plus 16x plus 15. Now I'm going to factor the trinomial, but I know that my answer will be negative 1 times a binomial times a binomial. So here we go. First term, first box. Last term, last box. Then A times C goes over here. So 4 times 15, which is 60. Factors of 60, 6 and 10, 5 and 12, obviously 4 and 15. I'm looking for two numbers that combine to give me 16. That's 6 and 10, positive 6x, positive 10x. So 6x will go in one box, 10x will go on the other. I'm going to take my signs out first. Then I'll take the GCFs. Greatest common factor of these two boxes, they both have a 2x. GCF between these two boxes, 6 is 3 times 5, 15 is, sorry, 6 is 3 times 2, 15 is 3 times 5, so it's 3. GCF, this is 2 times 2, 2 times 3, so 2x. GCF, 10 times 5, 5 times 2, 5 times 3. So my answer is 2x plus 5 and 2x plus 3. All times a -1. For number 5, I'm actually not going to do the box method, but I am going to just talk about what you need to do first. So we still need to factor out GCFs. And if you notice, these all have an x term. If you like, you can still do the box method for factoring out a GCF if that works for you. So then remember, from lesson 1, we would write the factors. 12 is 2 times 6, and then 3 x's. 14 is 2 times 7, 2 x's. 40 is 2 times 20, and there's 1 x. So all of them share an x, and then all of them share a 2. So we know that this is going to be 2x times the quantity. So this will be 6x squared. This will be -7x, and then -20. 6x squared minus 7x minus 20. Now what you're actually factoring is 6x squared minus 7x minus 20. Feel free to check the answer key if you need to see what the answer that is.